wabarakatuh. Good morning, ladies and gentlemen. First of all, I would like to express my thanks to the organizer of International Conference on Operation Research 2020 for the opportunity. Okay, let me introduce myself. My name is Edina. I'm a postgraduate student at 10 November Institute Technology of Surabaya, Indonesia. Today, I would like to present my research. Estimation of baseline hazard function on Cox model using maximum penalized likelihood with the case study brain cancer at Lab Edwar, Tangerang. Here is the presentation agenda. First, I would like to tell you about introduction. Second are methods. Third are result and discussions. The fourth are conclusion, and the last are reference. Introduction. Survival analysis is a statistical method where the variable to be considered is time until the event. The method that can be used in survival analysis is a Cox regression. In Cox proportional hazard regression, the variable should fulfill the proportional hazard assumption. But if there is a variable doesn't fulfill the proportional hazard assumption, the method that can be used are first is stratified Cox regression that is used by making the variable that doesn't fulfill pH assumption to be a stratum. And the second is extended Cox regression, where variable that doesn't fulfill in extended Cox regression analysis has interacted with a time function such as length. In Cox regression, the baseline hazard function is unknown. Without baseline hazard function, there will be important components missing, and the result cannot be used to report the whole model. The estimation method that can be used to estimate the baseline hazard function are Bayes' law, maximum likelihood, ordinary least square, partial likelihood, and maximum penalized likelihood. We know that maximum likelihood and ordinary least square used in a parametric estimation, and we also know that maximum penalized likelihood has smaller bias than partial likelihood. So in this research, we use maximum penalized likelihood to estimate the baseline hazard function and apply it to brain cancer patients. The next is method. Cox regression. In survival analysis, we can see that the survival time with independent variable which are considered to influence survival time by using estimation with a regression modeling. The regression model in survival analysis which is often used is Cox regression, where the relationship between dependent variable and independent variable has an exponential hazard function at certain time. Here is the model of Cox regression. When the beta g is equal to 0, then hazard function will be equal to baseline hazard function. But in Cox regression, the baseline hazard function is unknown. But we can estimate the baseline hazard function using several methods to get the maximum model result. One of the estimation method is maximum penalized likelihood. In this research, maximum penalized likelihood is used to obtain the estimation of beta and theta with Newton multiplicative iterative iteration. Here is the penalized log likelihood function. To make the estimate of theta have positive value, we have to manipulate the baseline hazard function like this. So we will get the new penalized log likelihood function. We know that the g theta is a penalized function. To estimate the beta with Newton-Raphson iteration, we need this step. First, we have to determine the first derivative of a penalized log likelihood function. The second, we have to determine the second derivative of penalized log likelihood function, and we have to input them in a Newton-Raphson formula. So the iteration will be stopped when beta with k iteration minus beta with k plus 1 iteration have a value less than epsilon, where the epsilon is 10 rank minus 6. The next, to estimate the theta with multiplicative iterative iteration, we need this step. First, we have to determine the first derivative of the new penalized log likelihood function. The k of multiplicative iterative iteration is solving penalized function to be a positive function and negative function like this. According to the Karus-Tucker equation, we know that the first derivative of the new penalized log likelihood function will be equal to 0 if the theta is more than 0, and the first derivative of the new penalized log likelihood function will be less than 0 if the theta is equal to 0. But in this research, the first derivative of the new penalized log likelihood function should be equal to 0. So here is the formula. The multiplicative iterative algorithm is updated with this formula. We know that the ratio of delta U1 over delta U2 could generate a negative iteration, whereas the multiplicative iteration should generate positive iteration. So it needs to be approached with a gradient algorithm as follows. The next is using line search to increase the theta with k plus a half iteration to be theta with a k plus 1 iteration, like this. So the iteration applies here, and the iteration will be stopped when the theta with k iteration minus theta with k plus 1 iteration is less than epsilon, where the epsilon is 10 rank minus 6, and we obtain the estimate of theta. After we get the estimation of beta and theta, we apply them on brain cancer. The data used is about brain cancer patients who are using electrocapacitive cancer treatment at CTEX Lab Edwar Tangerang. Data of brain cancer patients from 2012 until 2019 were 376. The study used data of brain cancer patients who had been on ECCT therapy for more than 6 months, so that the patient's data were 181. However, there were 9 missing values that should be deleted. Therefore, the total data used were 172. Here is the research variable. There are sex, age, monitoring frequency, surgery treatment, chemotherapy treatment, radiotherapy treatment, using herbal treatment, and the last is using on the radiotherapy treatment. Here is the data analysis step. First, we have to collecting medical history data of brain cancer patients who are using ECCT at Lab Edwar. The second is describing the characteristic of the brain cancer patients based on survival time and the factor true to influence their survival. The third is estimating the survival curve on brain cancer patients using Kaplan-Meier and Lagrange test. The fourth is examining the proportional hazard assumption. The fifth is performing tox regression model using maximum penalized likelihood on the data of brain cancer patients who are using ECCT. And the last is conducting parameter significance testing both simultaneously and partially. Result and discussion. Descriptive of brain cancer patient is used by looking at the survival curve to determine the characteristic of the survival curve of brain cancer patients based on factors that are true to affect the survival of brain cancer patients. Here is the Kaplan-Meier curve of all the variables. It can be seen that the Kaplan-Meier curve drops rapidly from day 0 to 500 or 6 months. In that time range, the probability of patients to survive is about 0.7. The following days decrease slowly until day 2000 or 5 years. The survival curve tended to be constant with a probability of survival is 0.4. Here is the Kaplan-Meier curve of each variable. First is sex variable. We know that the line of each group in sex variable doesn't intersect, which means that the probability to survive for male brain cancer patients are greater than the female. We also know in radiotherapy treatment variable, the both group doesn't intersect, And it also concludes that the brain cancer patients who don't do radiotherapy have greater probability to survive than those who do radiotherapy. And this also applies to survival curve based on monitoring frequency if we divide it into categories. First category is less than 2 times. The second category is 2 until 4 times. And the third category is over than 7 times. This figure shows that the more often brain cancer patients take control of the lab Edward, they will have a high probability to survive. From this figure, we also know the log rank test each variable. It is known that the sex, monitoring frequency, and radiotherapy treatment variables have p-value each less than significance level. Now this explains that the survival curve between the groups of male and female patients is significantly different, likewise with monitoring frequency and radiotherapy treatment, which also has a significantly different survival curve between each group. The next are in age variable, surgery variable, chemotherapy treatment, and using herbal treatment variable, and the last is using other therapy treatment variable, which the line of each group intersect each other, which means that there are no difference between group in each variable. From the log rank test, we also know that those variables have p-value each more than significant level. This explains that the survival curve between all of variables here are not significantly different. The next is proportional hazard assumption test. We know that the p-value all of the variable have p-value more than the significant level, so that we can conclude that all variables fulfill the proportional hazard assumption, and Cox proportional hazard regression can be used in this data. Here is the parameter estimate of Cox maximum penalized likelihood. We know that the likelihood ratio is greater than the chi-square, which means that at least one variable has significant effect on the model. And the monitoring frequency and radiotherapy status has a p-value less than a significant level 0.05, so they are significant variables. So we get the significant parameter estimate of Cox model. We know that the hazard ratio of monitoring frequency is 0.85, which means that the more often the brain cancer patient consults, he has a smaller risk of dying. We also know that the hazard ratio of radiotherapy treatment is 2.58, which means that brain cancer patients who do radiotherapy have a risk of dying 2.58 times greater than those who don't do that therapy, whereas radiotherapy helps to destroy tumor cells and prevent them from returning, which means radiotherapy can extend the survival time of brain cancer patients. This is because there are confounding factors affect the result of the study. From this significant parameter estimate of Cox maximum penalized likelihood, we get the model like this, where H0 is a baseline hazard function estimation and the value can be changed from time to time. The estimate of baseline hazard function can be present graphically as follows. Here is the baseline hazard function estimation curve. The death rate of the brain cancer patients from day 0 until day 500 up and down quickly. But after day 500 until 1000, the death rate up and down slowly until the day 1800 or 5 years. The death rate of brain cancer patients is a constant. The next is conclusion. Based on the result above, it is known that the more often brain cancer patients consult, he has a smaller risk of dying. In addition, it is also known that brain cancer patients who do radiotherapy have a risk of dying 2.59 times greater than those who don't do radiotherapy, whereas radiotherapy helps to destroy tumor cells and prevent them from returning, which means radiotherapy can extend the survival time of brain cancer patients. This is because there are confounding factors affect the result of the study. The second, we also conclude that the death rate of brain cancer patients from day 0 until day 500 up and down quickly, but after day 500 until day 1000, the death of rate up and down slowly until the day 1800 of 5 years, the death rate of brain cancer patients is constant. And last, I would like to tell you about the reference here. Here is the reference. Okay, that's all my presentations. Thanks for the attention. Assalamualaikum warahmatullahi wabarakatuh.